Good afternoon. My name is Ugochukwu Matthew. I'm here to present my assignment, my research work, blockchain-driven trust layer, a decentralized architecture for federated healthcare data warehouse system. The course advisor is Professor Demonson. The decentralizing is here. The abstract. Healthcare data warehouse system was developed to ensure secure data ownership and governance across internet-based platform. The technology system combines disparate hospital databases and Internet of Things medical platforms to support the ongoing 5.0 information technology development that enable federated governance and secure management of critical health data across various institutional networks. To address privacy and scalability challenges, the paper introduced BDAChain, a decentralized architecture integrating blockchain, federated learning, cloud computing, and AI. Built using design methodology, the framework enable privacy preserving, monitoring, sovereignty, scale analytics. The key findings shows significant improvements in the security metrics, authentication, increasing from the baseline by 38%, authorization 42%, auditability 47%, and anonymity 51%. BDAChain strengthens trust, compliance, and resilience, positioning itself as a transformative solution for digital healthcare ecosystem. Introduction. Healthcare distributed data warehouse systems integrate multiple hospital databases and medical information systems to enable federated access and sharing of critical health data across institutions and agencies of government for national health planning. Distributed systems do not offer cryptographic lineage verification. Centralized data warehouse repository are vulnerable to single point of failure and limited transparency, and hybrid systems are more likely to neglect enforcing uniform usage policy over heterogeneous data warehouse federated environment. On this note, this study proposed a blockchain-based trust layer, BDAChain, applying web data warehouse governance, smart contract and standard data for intent of data ownership, insurance, and enforcing terms of use. The architecture of what was designed, learning architecture-based cloud system, consider diagram, you see the distributed system being connected by being then being linked up using blockchain for information federation. Then you go to the problem why the research was conducted. So it took scalability and resilience throughout the entire sector, developing country digital economy. The proposed BDAChain solution combined blockchain, federated learning, AI, and enterprise data warehouse system to decentralize trust, enforce viable governance, and enable privacy-preserving analytics in line with health insurance, portability, and availability. So the essence of this is to enable the various health databases federate, also ensure compliance and security. Then this research has collected 3 research questions. One of them is how effective does BDAChain enforce policy compliance and ensure viable data ownership in distributed healthcare data warehouse environment? So this research question will actually guide the implementation of the framework to test whether this question will actually answer. Although it was fully to say, yeah. It's part of a mixed methodology, combining history review and computational modeling to design the scientific artifact for BDAChain framework in achieving federated healthcare data warehousing system. The initial phase involved a systematic review of 20 scholarly articles focused on blockchain technology, and data warehouse technology for care system published between 2020 to 2025. In the study, design science research methodology were used to provide a structured approach to developing and evaluating innovative solutions to a complex computational problem, making it highly suitable for guiding the implementation of BDA computational framework. The BDAChain implementation further incorporated actor network theory in addition to design science research methodology to guarantee both social organizational alignment and technical rigor. So, and complement this by mapping relationship among human actors, clinicians, policymakers, patients, and non-human entities, Internet of Things device, cloud systems, smart contracts, highlighting how trust, compliance, and governance emerge from these interactions. When combined, design science research methodology and allow BDAChain to provide a socially embedded, decentralized, and verifiable healthcare information system management. Then we have to go to this design. This was calculated and deployed on TensorFlow federated to create a federated learning system. Quality is provided as well as diagrams expressing reinforcing framework Then this study used UK National Diet and Nutrition Surveyor dataset to implement BDA framework. First cut-off records with complete anthropometric, biochemical, clinical, and dietary variables divided into 3 nutritional groups on average, normal, and overweight based on body mass index threshold and info markers provided expectation for the data set analysis. In order to replicate real-world federated learning and ensure that raw data remain at the source, hospital clinics and internet of medical node state locally subset. This design enables secure collaboration, strong predictive institutional modeling, in order to reduce class imbalance. BDAChain uses stratified 70-20-10 split for data training, validations, and test data set. Okay, so the BDAChain data set training uses a lightweight feed-forward attribution gradient for algorithmic optimization for input in conjunction with the software to coordinate data training. 20 input nodes, a hidden layers with 10 neurons, and a 3-node output that represent different categories make up the application. Then we go to the system framework. As seen in figure 2, this is the figure 2, the BDAChain framework for data ownership implementation. Then, as seen in figure 2, the BDAChain system architecture unifies 5 major healthcare data warehouse system into a single NHS data warehouse unit. In excess of this, so this centralized platform facilitates effective management of various clinical assets by supporting and organized workflow into extraction, transformation, processing, significantly, indexing, and recording. In order to ensure that all process is prepared by impediments to manipulation, BDAChain incorporates blockchain across layer during the indexing stage. This study systems throughout the healthcare system. This is the framework. This is transaction. We should see BDAChain efficacy in policy compliance, scalability, and secure collaboration. The study of fast answer to research question. First, using blockchain provenance, hashed model update, and smart contract that verify contribution and the guaranteed transparent participation. BDAChain enforces policy compliance and verifiable data ownership. Then the model evaluation. The model we evaluated in this order. Model evaluation, the integrity, verification, increased by 20% on baseline. Yes. Then look at the metrics of the model. All the parametric index that were tested. It shows a very good prediction. Then the other diagram here also shows the performance of BDAChain, the framework that were proposed, as against other machine learning that were compared along with it. So it performed better. The tools and the materials that were used, the framework that were used to implement BDAChain show better performance and help with better machine learning that were compared along. The conclusion: BDAChain confirmed its scalability, forbearance, ability, demonstrated its potential by policymakers and administrators and NHS authorities with useful insight. With quantifiable gain of 42% in integrity, verification, in the data linear tracing, the policy enforcement increasing. All these numbers in security BDAChain confirmed traditional framework, ultimate independability, and fault tolerance. This result highlights BDAChain potential as a strong data ownership compliance framework for cloud-based and internet-of-things healthcare system. The study concludes by highlighting BDAChain's functions as a robust, trustworthy, and future-ready infrastructure for digital health governance, in line with the more general objective of Healthcare 5.0. That is the end of the presentation.